Good morning. I hope you had an enjoyable evening yesterday and are ready for another day of talks. Because today we'll start with something lighter, as I will be sharing my learnings from onboarding over 10 university graduates in the past 5 years. And I think I should start by giving myself some credibility, why I might be even talking about that. I work as a senior AI engineer at Procter & Gamble, and I joined P&G during my second year of master's, and I started there as just a data scientist, but then I got exposed to Scala early and fell in love with the language. And I went through the whole route of writing simple Spark ETLs into some post and pre-processings within our ML pipelines, to then writing full-on type-level applications. And what I want to do first is to set the stage. Let's put ourselves in the shoes of the university grads that are exposed to our applications. Let's think what they see, because you just finished your studies. You are excited. You are yearning to learn. You want to prove yourself. And you start that onboarding session with your senior after finally landing that job. And he decides to show you the graph, architecture graph of the project you're working in to see actually what you will be working with. And you say something like this. And you know those icons. You had SQL at your uni. You had a little bit of Databricks. Yeah, you had a little bit of cloud. But the key behind all of this is that you had it only on academic level. You do not truly know yet what those technologies mean on enterprise level. And this, in general, is overwhelming by itself. And I want to keep that in mind when we're going through the whole talk, because there's always a complexity, and there's always a challenge for those newer members in our Scala community. So even though what I will be presenting today, for some of you might just be best practices, I hope you will take a second look at them, as I will show you why we might have some of them. Maybe they will not really apply to your projects, but hopefully by the end of the talk, you'll actually look at your code and realize there might be something that I might tweak to make the onboarding of new members easier. And the very first thing I find is the most important, even if you disagree with my takes later, is that whatever you have in your code, whatever setup you have between your repos, within your project and your team, consistency is paramount. It is the most important part, because it doesn't only apply to the junior members who do not really know yet what they are dealing with, but it also applies to a senior dev that's joining your team. Because they might be onboarding into one project, learn your best practices, how you approach coding, how you approach your code structure, and then jump into another project, and suddenly all they learned was for nothing, and they need to relearn everything, adding additional layer of complexity. And let's have one thing in mind as well. Whenever you approach software development, you always prioritize over something. And usually it's performance, but in my case, I'll be prioritizing the readability and maintainability for the newer devs. So let's start with the project level tips. And the first idea that I would like to propose, that I know might not apply to every team out there, is idea of stepping projects. So let's imagine within your scope, within your team, you have few projects that you are working on. One of them might be a simple ETL job. It might be triggered by some event. You just use it, run it using Spark, simple Scala, nothing really fancy. Then you might have some kind of a batch scheduler that's already using functional Scala, but it doesn't have all that I/O jazz. You do not have FX systems. You just have more complex and better ideas used within Scala. And then you actually have your backend for your UI or whatever service you're exposing to users that's written in the type level with cuts effect, all that jazz that we love here. And you can clearly see that there is like a stepping structure when we're talking about those projects, because you have the simplest one being ETL, then you have something slightly more complicated. And usually when you're onboarding a new person, you want to give them something that's a quick win for them, that they learn only part of your stack and then move forward learning more and more instead of being overwhelmed by the complexity you already have in place. And this setup allows you to, first apply that academic knowledge to Spark, SQL, that you already had at uni, then move over to more and more complex stuff, and maybe after a year, in your simpler applications within your team, they can go and learn that tagless final approach, finally learn what dev is about. And here, I would like to also add one more thing. When we're talking about the stepping projects, you could keep the consistency that I mentioned, because consistency is key. So even though they might be dealing with something completely different, you can still, within your repository, keep the code structure similar. And yesterday, when I was talking to one of my friends here at the conference, Camila, and I was talking about this specific point, she gave a very good example that I really like. And that is, if you have a mess in your house, and you're looking for socks, you don't really know where to find them because everything is so messy. But if you have a mess in your socks drawer, you can at least figure that one out because you know where to look for socks. And I think the same thing applies here. Even though we are working with something completely different, you might be having different projects, you can keep the folder structure the same, because especially here I'm proposing any kind of domain-driven approach, but whatever applies to your team and is consistent is best. Because this way, a newer person learns that first repo and then can translate the learnings they've already had, and they know where to search for stuff moving forward. And there is one more thing here that I would like to say. This is obviously an example that not every team will have. Like, you may be working only with, say, complete microservice suite. And in that case, you might have that one microservice that a new person is thrown to the wolves and has to learn the tagless final and whole type level approach on the first day of the job. Hi, Nella. And even though you have to do that, you still might have that one service that's doing something slightly simpler. You might have that one that just exposes your database and maybe has all the database queries that you have in your team. And those first tasks might be only handling a certain subset of the complexity you have, be it Doobie in this case, and how encodings and decodings work in the whole type level applications. And now that we're done with some ideas on the project level, let's get into some code level ideas that I found were better for newer members. And throughout this talk, I'll be giving mostly standard library examples for simplicity's sake. I know you might have completely different approach to, say, reading JSONs. You might be using different libraries, but I find that the ideas still translate between one another library, and whatever libraries you keep will still work with some of the ideas that I will have. And I find the one thing that can be a gatekeeper for the newer people within your team is actually how you define your configuration files. Because you can pass them in many ways. I don't really care if you use JSON, application.conf, Hawken files, like whatever you have in your team and that works, that's fine, but I will give you examples using Java util properties. And this is a very simple example, but what stands out to me here is that we're actually, when reading the code, my mind immediately goes to the cloud provider here and how in the apply method we actually have a default value AWS. And my brain thinks like, wait a minute, do we have another cloud here? Why is AWS default? What is the other actual value that we might be working with? So you might go to senior, you might look through your docs, and there might not even be an explanation. And the same thing applies to machine learning model. Why do we have Lasso as the default? Should I look for other values possible somewhere else in the code? And this is just an entry point to the application. And what I would like to propose here, and from what I gather most of you already are doing, is just go with domain-driven design. Because from my learning, the technical stuff that you learn on a project is usually the easier part, because you have just a part of code. You can Google it, especially nowadays with the LLMs everywhere. You can also ask the LLM, just paste the code. Do not tell your HR that you pasted the code into ChatGPT, and then it will explain it to you, right? But when it comes to business knowledge, it can get lost over time because your senior might not yet know it. It might be on the outdated Confluence page from 6 years ago. The person who was responsible for the requirements of the project is not anymore in the company. So I find that learning the domain is actually harder sometimes than the actual technical stuff, because you can read it and you can find it on the internet. And the obvious example, hopefully everyone uses them here, algebraic data types. But there's one good thing also here, that it gives you all the information about a given type. If you're a newer user, you do not have to search for information outside of the repo here, because not only you can have all the possible values, if you move further even with this idea, you can provide all the auxiliary functions, extensions, whatnot within this algebraic data type. So you keep more information what's happening with this type here, instead of external documentation, or worse, your senior's brain that he's the only person that knows it and maybe he quits the company. So the same logic applies to machine learning model. And there is one thing when we actually finalize the newer version with the simple ADTs, is that we just eliminated default values. And I find that the default values are actually a bane of configuration files when it comes to newer people, because one of the best ways for a newer person in your team to actually learn what's going on with your code is sometimes to help you out with a ticket. Your code fails, you just throw them, analyze it. Let's just learn it as you go, figure it out. And then they go into why it failed on the runtime, what happened, because you might have an ETL. We all would love that our code would actually never fail on runtime, but there's always network issues and whatnot. But they would look at the configuration file that was supplied by the user, and then realize that some of the values actually, when they are looking through the code and finding the bug, are not yet there in the configuration file. So they have to take that mental note and jump throughout the code. What are the defaults? Where they are supplied? And it is just another layer of complexity when learning what's happening with your code. And I am aware you need to provide those defaults somewhere, but you can just use it as your environmental variable somewhere on your Kubernetes cluster or whatever you have set up there. And another thing that I would like to touch upon is boxing your primitive types. And I know it comes with an overhead. We have, for example, here, just a random forest configuration file. And random forests are a very simple model. You just have a number of trees, max features, let's say for simplicity's sake, and those are defined as integers, but if you were to read the documentation, they are actually positive integers. And what you could do is, obviously, if you have refined within your scope, just use refined, have it defined there. But if you are not yet using refined, you can just box them, and by providing the verbose types whilst boxing them, you can also provide, I do not suggest that, you can add require, etc., to give more context when you're reading just the type, or give a Scala doc that would tell more about it. And I find there's another benefit to that, because we all know those moments that we missed out on two integer calls within a function, or to string falls, we miss the sequence because the naming of the variable is actually not what it's supposed to be, because that was written 5 years ago and we never actually cared to change the name of the variable. But here, as we just follow the types, we cannot make the mistake unless at the end of the word, when you unbox it in the final call, but you still had it in your function definitions. And as we're avoiding default values, I would suggest we avoid them overall in your code, because it is sometimes very tempting that we have tests. And you have that one functionality that you need to write 20 tests for. And every time you would have to write directly the same parameter because you're testing the other parameter. And it is so tempting to just add the default. But in your actual production code, that function is called only twice with 2 different values. So why would you be supplying default parameters? And there's one reason that I also dislike defaults, is that, let's say we have this simple example with 2 database calls. One of them has a default of a connection. Don't do that, by the way. Don't expose it in the code. And the another one doesn't. And when you actually look at some kind of call on those functions, I have this simple mocked code. You read it line by line, and you see that there's one database call, then there's another database call, and my brain already, when reading such code, without hovering over it, would think, do we have defaults? Is it a function overload? Or even worse, did someone name a case class lowercase and has 2 constructor methods? And this is something that whenever you would be inspecting your code and then looking at, for example, some other call, my brain would immediately think, okay, there might be something hidden here. You do not have it explicit, so it creates another mental burden on you to keep more context in your mind whilst reading the code. And furthermore, when you're actually doing a code review, if you make an assumption that throughout your whole code you're never using default values, GitHub will actually be a good place, or any kind of VCS for that sake, will be a good place to just read the code and you know what's happening just by reading the code, and you do not have to look for some hidden additional things within it. And this goes directly to implicits, as they are kind of default values, but like very hidden. As I would suggest we always go with principle of least power and keep the consistency. Because I would suggest, unless you're going with implicit heavy patterns, like you're actually going type class pattern, you're going the full-on type level approach, where the design for usage of implicits is just written by the design pattern alone, you might end up with use cases like this, where I think every ETL job you've written had to have Spark and Logger. And those are perfect examples of implicits that you keep throughout your whole application, because those are just your infrastructure. There are no parameters. You just have to have it in the code. And maybe there is something more. But if you keep your implicits set from the start of your application, when you're reading the code, you know what to expect in the implicit scopes. So you do not have to end up in a situation like this, where you decided that your implicit is actually your whole environment, which is, at this point, parsed configuration file, which contains everything, including your loggers, configs, maybe some parameters that you would be calling. And you end up with a series of function calls where one function is nested within another, within another, within another. And at the end, with the last function, you just call env.config get one value. And whilst reading that code, you will be going through, oh, yeah, in that situation, every single function that you will be working with, you would realize that there might be something hidden from you. Whilst if you knew that you should avoid keeping like that whole environment file, you wouldn't be looking for, is there something more here? Is there some parameter called here? And then you end up going X-ray mode throughout your whole code, or if you're just going through GitHub, you do not have that case. And by the way, by giving this example, if someone can please make sure that Databricks releases runtime that supports Scala 213, I would be very thankful. Moving forward, I would, keeping the explicit approach, I would also try to add your database description to repos, because this is one of those things that can cause you problems on the runtime as well, even though we might be a type-safe language. Unless you call that database, you do not know if you actually call the correct sequence of columns. And probably all of you had that lovely moment of ending up with a code. You want to check what's the actual database schema. You open the beaver, then go somewhere else, then the beaver disconnects you after 5 minutes, and then you have to go back, restart it because it doesn't want to connect you again, you can avoid it by having it in a repo. And there's additional benefit, as you can even use libraries like Flyway, Liquibase, anything that helps you out with versioning of your databases, because you'll have your definition written out somewhere in the code. Obviously, after the versions, you will not have the direct name of that database, but you will at least somewhere have the description that a newer person within your team doesn't have to look outside. Your repo is a single source of truth for them. And furthermore, as you have something like this set up, it helps you out with releases. I'm pretty sure you had a situation that you moved from staging to prod and you forgot to add something to a database, and then you were thinking, what is wrong? Why it's not working? Because that change on the database in staging environment happened 2 months ago and you forgot about it. And there's additional benefit that it simplifies your integration testing with test containers. And this idea about defining your database schemas somewhere in a repo also applies to another kind of structured data that you might be working with. And I find the biggest example that some of us might be working is just Spark. Yesterday it was mentioned that you never really know if you actually call the correct data frame unless it happens. And you can keep the amount of errors the newer dev encounters while writing Spark queries by just providing some kind of structured definition of a Spark data frame, be it using frameless, if you're more in the type level approach, or if you're just using Spark data sets, or you might have something custom made that fits your use case. But this is another thing that makes your repo a single source of truth, where you can find your structured information instead of having to use external softwares. And another thing that all of us did at some point is verbose error types, and I would like to add one more context for a newer person, especially in like more of a domain-driven approach. If you have a specific domain, you can also learn the behaviors of that domain when you have all those errors grouped up in one place. It also helps out with handling. But when it comes to readability as a newer person, you have everything given to you on a platter, and you know what are the expected behaviors of your code. And one thing that I wish I did more, now that I have younger members that are looking at Git blame and asking me, why did you do that? And my answer is, I don't know why I did that. I wish I knew. Is that nowadays, especially with like GitHub Copilot, it is easy to have a description of your pull request that just tells you, yeah, that's what's happening in this pull request. Cool. I could also deduce that from the code 3 years later. Like you can read the code, you can throw it into an LLM and then realize what it's doing. But there is that context of why are you doing this that gets lost over the years. So keeping that within your pull requests, unless you change your version control and your pull requests are gone, well, then that's a problem. But if you keep it, you will be able to go back and learn what you were thinking 3 years ago, because I find that quite a lot that newer team members ask me why we had certain things set up, and because I didn't really document it while I was writing a code, that knowledge is lost to the ages. And obviously this can be also done with like Jira tickets assigned to your GitHub pull requests. And I would like to finish on one sentence that I try to keep to my heart, because we will read way more code than we will ever write. And I try to, whenever I think about adding that new nifty, fun library that will solve my problem, I like to keep in mind that what benefits me here will prove as additional complexity for a next person that will be onboarding on the code. And I try to think that at some point people will read my code more than I will actually have spent time working on it. So that's a thing that I try to live by, and I think we all should. And that's, now that we actually done this, and I still have 5 minutes, I would like to add one more thing that I have saved. And an idea how to actually give something for a start for a newer dev. When they're just on board, instead of giving just a task, because we probably all went through Martin's Coursera course or something, and I've went through all of those. I've tried out a lot of entry-level courses for people who joined my team, and by trial and error, I actually found out what kind of worked for them. So obviously, thank you, Daniel, for your code and your presentations, because those were very helpful throughout my experience. But I find that if you have someone that didn't yet have experience with Scala, the Rock.jvm courses were super helpful. If someone already had some software engineering background and they had some experience with previous companies, usually Scala Essentials book was more a thing that got them up to speed quicker when it comes to just basics. And there is one more thing that I really enjoyed as an idea, is that you probably, as a student, already did some of the algorithmic exercises, so you're familiar with that. So Advent of Code is a perfect thing to just follow up on, because it will give you something that you already had at uni, but whilst you're going through that training on Rock.jvm or going through that book, and you're learning the next chapters as you go through, you can apply this knowledge to the next day of exercise in Advent of Code and just have something tangible that you can also then compare to what people were doing in the Scala community, because the Scala Center has their solutions to Advent of Code, so you can just compare, learn, and this also gives you a quick turnaround if you do not understand something, that you can ask a senior member, hey, what's happening here? So that's my big advice when it comes to onboarding your people. And that will be all from me.